All right, take a look at this. The Sidmouth coastline in Devon. On the surface, it looks pretty simple, right? Just a long stretch of pebbles. But what if I told you that every single one of those stones is a character in a really incredible story? A story that involves, get this, ancient deserts, mind-boggling natural power, and a surprising will to survive. So, how can a pile of pebbles tell a story that's millions of years old? It's a fantastic question. And the answer, well, it's going to take us on a wild ride. We're talking 250 million years in the past, through the last ice age, and all the way up to the really complex challenges we're facing right now. So come on, let's start digging for the secrets hidden right here on this shore. Okay, so to understand this beach, we've got to look down. I mean, way down. The foundations of this whole coastline were laid hundreds of millions of years ago. But, and this is the interesting part, the story isn't one smooth, continuous line. There are some big gaps. I mean, just look at the scale of time we're dealing with here. It is absolutely staggering. You've got these base layers of red rock from the Triassic period. That's 250 million years ago. But then the layers on top, they're way, way younger. So what does that mean? It means there's this huge gap in the middle. Millions of years of rock are just gone. They're missing from the geological record, right here on the coast. You know, the easiest way to think about it is like a big geological layer cake. Seriously. At the bottom, you've got the oldest layer, the Otter sandstone. In the middle, there's the younger Mersha mudstone. And then the icing on the cake, the most important layer for our story, is right on top. It's the Upper Greensand and Clay-with-Flints. And that right there is the treasure chest. Why? Because that's where most of the hard, flinty pebbles on the beach actually come from. Okay, so we've got our raw materials, right? The cliffs are basically a factory for pebbles. But how did all those pebbles get piled up into this huge shingle beach? Well, for that, we need to hit fast forward and jump ahead in time, all the way to the end of the last ice age.
So picture this. The massive ice sheets are melting, sea levels are rising, and these incredibly powerful waves start acting like giant bulldozers. They're just shoving unimaginable amounts of shingle towards the land, building up this truly massive feature they call the Great Beach. It was a colossal ridge of stones stretching all along the coast. And the beach we walk on today, it's really just a ghost, a tiny surviving piece of that ancient giant beach.
And this is where we get to the central conflict, the real drama of the story today. It's a constant tug of war. In one corner, you have nature. That's the relentless eastward drift of pebbles, the raw power of storms, just constant change. And in the other corner, you have us. 2 centuries of human engineering, seawalls, groins, rock islands, all of it designed to do one thing: bolt the coastline in place and stop it from moving. If you really want to understand the sheer power of nature on this coast, we need to talk about Chit Rock. It was this famous local landmark, a huge sea stack that stood an impressive 40 feet high. Just imagine that, a solid pillar of sandstone. Or at least that's what everyone thought. And then it was gone, just like that. A single brutal storm in November 1824. The sea literally smashed it to pieces. All that's left is the low reef you can see today. It's just a stark, brutal reminder that on this coast, nature always gets the last word. So, you hear about this constant battering from the sea, and you'd be forgiven for thinking, well, nothing could possibly survive there, right? But you'd be wrong. Because against all the odds, this incredibly hostile environment is actually home to a surprisingly tough and really unique ecosystem. I mean, just think about it from a plant's point of view. A shingle beach is an absolute nightmare. The ground is constantly shifting under you. Any fresh water just vanishes instantly. There are basically zero nutrients to eat. You're getting sprayed with toxic salt all day long, and you get battered by storms. It is, no exaggeration, one of the toughest places on Earth for anything to try and grow. And yet, right in the middle of that nightmare landscape, you find this. In front of the Belmont Hotel, some amazing local volunteers have helped create a protected sanctuary. They call it the Beach Garden. Now, this isn't a garden with roses and manicured lawns, not at all. It's a haven, a refuge for the super rare, super specialized plants that are tough enough to call this impossible place home. And the survival strategies these things have come up with are just fascinating. So to deal with the unstable ground, sea kale grows these incredibly deep taproots. To stop from drying out, the yellow-horned poppy has these waxy, silvery leaves. Even the birds have adapted. The rock pipit has feet that are perfectly designed to grip onto the slippery man-made sea defenses. It's amazing. And you know what's cool? Life isn't just on the shingle itself. It's incredibly opportunistic. It finds a little niche, a little foothold in every single zone. You'll see lichens clinging to the hard sea defenses. You'll find tough rock samphire taking root in tiny cracks in the seawall. You'll even see birds like turnstones that have learned to patrol the man-made pavement, the esplanade, looking for food. Life just finds a way. So this is what it all boils down to. This is the modern dilemma. You have a town that, understandably, needs protection, but it's sitting on a coastline that, by its very nature, is built to move. And that right there is the central conflict of Sidmouth's story today. And this creates a really serious problem, something scientists call coastal squeeze. Think about it. Normally, as sea levels rise, a beach would just kind of migrate inland. It would move with the water. But when we build a hard seawall, we've basically created a trap. The beach is literally caught between a rock and a hard place, the rising water on one side and an immovable wall on the other. And eventually, it just gets squeezed until there's nothing left. And let me tell you, the pressure is mounting. Fast. Recent research estimates that the eastern cliffs are eroding at a pretty shocking rate, 2 meters per year. To put that in perspective, that's like losing the length of a car from the coastline every single year. The situation is way more urgent than anyone thought. So, what's the plan? Well, the current response is a big engineering strategy. The goal is to hold the line, and it's got 3 main parts. First, they're building a new groin. That's one of those barrier things that juts out into the sea to trap shingle as it moves along the coast. Second, they're raising the seawall to stop the big waves from crashing over. And third, something called beach nourishment, which is basically what it sounds like. Physically trucking in and dumping huge amounts of new shingle onto the shore to build it all back up. And so all of this leaves us with a really fundamental question. When you're facing these immense natural forces, for a coast that was shaped by millions of years of change, a coast that is supposed to move, is trying to nail it down in one spot always the best strategy? Or do we need to learn how to adapt and move with it? It's a huge question, and it's one that Sidmouth and really coastlines all over the world are going to have to answer.